So today we're going to work on endothermic and exothermic reactions. And a good way to review this is by writing out the words endothermic and exothermic. Now both of these words have the same root, thermic, and thermic means pertaining to heat. And so for endothermic, we have a different prefix, endo. Endo means inside or into. And so endothermic would be heat going into the reaction, whereas exothermic would mean heat leaving the reaction, exo meaning outside. And so with these two words in mind, we can take a look at how everything ties together. We can write out our generic equation, A plus B goes to C plus D. And so you can start thinking about how an endothermic and an exothermic reaction would see heat in this sort of equation, like so. So for an endothermic reaction, we have A plus B goes to C plus D. Where would the heat go? Would it be on the left side of the reaction or the right side of the reaction? In the reactant side or the product side? So for an endothermic reaction, we have heat entering the reaction. So we would see heat on the left side. And then for an exothermic reaction, heat is leaving the system. So we would see heat on the product side. Now, this is only one of a few ways to show heat in a chemical equation. Another way, instead of writing the word heat, is to write out plus, let's say, a certain number of kilojoules of heat. This, in sense, still refers to the fact that this equation is still an endothermic reaction. It really only matters on which side of the equation the heat appears. That's how we can decide whether or not this is an endothermic reaction or an exothermic reaction. Now, there's a couple other ways to determine whether or not we have an exothermic or an endothermic reaction. One of those ways is through an energy diagram. So I'm going to draw an energy diagram. We're going to assume that on the x-axis we're doing the forward reaction. And then on the y-axis we have an increase of energy in joules. Okay. So we're going to arbitrarily decide that our reactants is on this energy level, and our reactants being A plus B. So for an endothermic reaction and an exothermic reaction, there's a different energy diagram, and it really depends on where our product lies. And so we're going to write out some transition state that we're not going to worry about right now. That's an intermediate form of our reactants and our products. And then we can write our product here being C plus D, or we can have our product here still being C plus D. So the difference is you can imagine whether or not this energy diagram from A plus B ends up at this higher energy level or at this lower energy level. And as you can see, there's a change of energy here, and there is also a change of energy here. So take a second and think about which energy diagram corresponds with endothermic and which corresponds with exothermic. So this energy diagram corresponds with an endothermic reaction, as our products are at a higher energy level than our reactants are. This sort of change in energy is the heat that is required to start the reaction. For an exothermic reaction, we would actually see the opposite. Exothermic reaction, A plus B goes to C plus D, goes down. There is a change of energy where there's less energy in the system after the reaction occurs, which makes sense. As heat is leaving the system, we're also losing energy. Less energy in our product state makes them more favorable and more stable. So this is just a quick overview of what exothermic and endothermic reactions look like. As we said, an endothermic reaction would see heat on the left side, on the reactant side, and an exothermic reaction would see heat being released on the product side.